So today we are going to start chapter 7 with chemical formulas and chemical compounds. So you guys are going to learn how to name compounds and write chemical formulas for compounds. Oh. Oh. So the chemical formula will give you the number of atoms of each kind. So it gives you some examples there. Like CH18 tells you there's 8 carbon molecules and 18 hydrogen molecules, or hydrogen atoms, to make up the one molecule. Al2SO4 that 3 on the end carries through anything in the parentheses. So Al2, that means there's two aluminums. The SO4 is called sulfate. It's a polyatomic ion, but the 3 carries through, so there'd be 3 sulfurs and 12 oxygens. That's how that would be counted. Monatomic ions are formed by gaining or losing electrons. So if we look at the S block, you guys remember where the S block is? First 2 groups, groups 1 and 2. So in group 1, like lithium, sodium, potassium, how many valence electrons do they have? They only have 1, right? In group 1, they have 1 valence electron. To be stable, they want an octet, so they want 8, right? So is it easier, do you think, to gain 7 electrons or to lose that 1? Lose the 1. So if you lose an electron, you're losing negative ions, or negative electrons. If you're losing negative charges, you're going to become more positive. You have more protons now than electrons, so that's why they become +1 charged. Group 2 has 6 valence. And is it easier to lose 2 or gain 6? Lose 2. Easier to lose 2. So when you lose 2 electrons, you're losing 2 negative charges. So you're becoming more positive by 2, so they become all +2 charges as ions. The P block, like fluorine, chlorine, and bromine, the halogens, how many valence electrons do they have? Fluorine, chlorine, bromine, group 17. 7, and they want 8, so is it easier to lose 7 or gain 1? Gain 1. So if you gain an electron, you're gaining a negative charge, so you're becoming more negative. So you become a -1 charged ion. Oxygen and sulfur, they have 6 valence electrons. It's easier to gain 2 than lose 6, so they become a 2- charge. So that's how we can use the periodic table. There's certain trends there that we can use. Now the D block, the transition metals, they can have a 2+ or 3+, sometimes even a 1+ or 4+ charge. And some elements can have multiple charges. So here is an ion sheet. You'll probably want to keep this. 3 more. Yeah, I'll give you, there'll be a bunch of questions. Shoot. I'm going to have to copy 3 more of those for the U3. I thought I had enough over here. Nah, I'll do it later. But if you look in the D block on that chart, like look at iron, Fe. What charges does it have there? A 3 and a 2. So it can form a 2+ ion or a 3+ ion. When we name them, when we name a compound with iron in it, we'll have to indicate which ion it is. And it will come into play when we write the chemical formula also. So nomenclature is just a big term for naming compounds. So if we name a compound that is binary, meaning there's only 2 ions in it, so we have a monatomic ion binding with another monatomic ion. The cation, what charge does the cation have? Positive. Remember, the T in cation looks like a plus, so it's a positive ion. Cation, you don't do anything, you just name it with the element's full name, you don't change anything on the element name. The anion, which is the negative ion, the ending of the name is dropped and you add IDE. So like chlorine, you drop the INE and you add IDE, so you have chloride. Same with oxygen, you would take off the ending and be oxide instead of oxygen. So binary ionic compounds are composed of 2 atoms. They are neutral compounds, so all the charges need to cancel each other out. So if you have a +2 charge, you need a -2 charge to balance it out, or you need 2 -1 charges to balance out. So the cation is always written first. You cross over to balance the charges, and I'll go through an example to show you what that means. And when you name them, the name of the cation is always given first, and the anion is second. Now that rule, the cation first, the anion second, is for any ionic compound. We'll use that. So, here's a few problems. I started the... Oh, no. No. Anion. Okay, it is working. I want this to show up on the side so I can actually write. Hold on. Really? Come on. On. There we go. Okay, so zinc and iodine. Look up, what's the symbol for zinc? Zn, and what charge does it have? A 2+. So let's write Zn and a 2+ charge on it. I'm waiting for my pen. And then iodide. Iodine would be iodide on your chart. What charge would it have? And so we have iodine -1. So how many iodines do we need to balance out the 2+ charge here? 2, right? 2 negatives to balance out the 2+. So we have Zn, and we'd have I2. That should be 2. That would be our formula. When we talk about crossing over charges, you're going to take the 2 here, not the 2+, but just the 2, and cross it over down here. And then this is like a 1-, so you'll take the 1 and cross it over here. We don't have to show the 1, but if you would just do the crossover, we would still have ZnI2, which would be your correct formula. So zinc and sulfur, we know zinc is 2+. What about sulfur? 2-. So how many sulfurs or sulfides do we need to balance out zinc? 1. We only need 1 of each. Because we have a 2 plus and a 2 minus. They balance each other out. Or if we cross this over, if we crossed over the charges, we would have Zn2, S2. And for ionic compounds, we always want to reduce the subscripts that we crossed over. So the 2 and the 2 can be both divided by 2 and get 1, and when we don't have to show 1s, so it would just be ZnS also. So we get the same answer. Either way, you would work that problem out. How about potassium and iodine? What's potassium? And iodine is? So how many of each atom do we need to balance each other out? 1 of each. Or if we cross over the charges, we're crossing over a 1 and a 1, so we don't show 1s as subscripts, so it's just Ki. How about magnesium chloride? Magnesium has what charge? A 2 plus, and chlorine, -1. So how many chlorines do we need to balance out the magnesium? 2, so we would have MgCl2. Or again, if you just cross over the charge, this is a 1, we would still have MgCl2. How about sodium and sulfur? Sodium has what charge? And sulfur or sulfide, 2 minus. So this time, how many sodiums do we need to balance out sulfur? 2. So we'd have Na2S. Or if we cross over the charges, the 2 would come down here, the 1 comes down here, we still have Na2S. Questions on this so far? Yes, they're getting the numbers off the paper. You know what? For right now, these are the old ion charts we used to use. I like the new ones better, but you guys can use this for right now. At least you can look them up then. Whoops. So the monatomic ones are on this side. Yeah, so these are the numbers. They're getting like S2 minus. So we're working off this side first. Okay, aluminum and nitrogen. Al has what charge? 3 plus, and nitrogen? So how many of each do we need to balance each other out? Just 1 of each. So Al, N. If you cross charges, you would have gotten Al3N3. The 3's can both be reduced, and you would see you would have Al, N. Okay, let's try this. Now they give us the compound, and we need to name them. So how about AgCl? What would that be? Silver chloride. ZNO? Now, oxygen is a 2 minus charge. Why isn't there 2 here? Zinc is +2, so they've been canceled out already. They just need 1 of each. How about the third one? SRF2? Strontium fluoride. This one? Number 56.
Barium oxide.
And the last one? Calcium chloride. Okay, for binary compounds with elements that form 2 or more cations, so in that D block where they have, like iron can form 2+ or 3+, we have to use what's called the stock system to name them. We're going to put that element's charge in parentheses in Roman numerals. So if it was iron 2+, we'd call it iron 2, and in parentheses we'd have the Roman numeral 2 for iron 2 and then oxide or something. So here's that example. Iron 2 would look like this. Iron 3 would look like this. We have to indicate which iron atom. Now you only use these Roman numerals for the D block elements that form multiple cations. So for like sodium only forms +1, so we don't have to use the Roman numerals. So all those examples we were doing already, they only formed one ion, so we don't use the Roman numerals. What? Probably 4. So make sure you know how do you write 4 in Roman numerals?
An I, then a V.
Yes, an I, then a V. So in this example, CuCl2, we'd have to take a look at this. Chlorine has -1 charge, and there's 2 of them, so there'd be a -2 total, which means copper must have been a +2. So when we name this, it's copper 2 chloride. What charges can copper have? A +1 and a +2? So we'd have to determine whether it's a +1 or +2. So if you look at this, chloride is a -1, and we have 2 of them. So there's a total of 2 negative. So to balance that out, copper must have been a 2+. Does that make sense?
Yes.
For the D block elements, you have to use the stock system. Oh, there's a 6?
What's 6?
Plutonium. Okay, so 5 is V and 6 would be a VI, but 4 is IV. So let's write the formulas and give the names of the compounds formed by these ions. So Cr3 and F-. What would be the formula first? And what would be the name? Okay, can chromium form more than one ion? Yes, so we need to just put chromium 3 fluoride. How about the second one? What's the formula? And what would be the name? Copper 2. Because copper can form, we already said +1 and +2. So we have to show which one it is. And it's always based on what its charge is. The second one, or the third one? Yep, just FeO. Iron 2. Now this one, if you were just given this compound here, how would you know that it was iron 2? It's either 2 or 3. Oxygen's a 2- charge. So to balance it out, iron must have been a 2+. So that's how we would know it's iron 2 and not iron 3. How about lead and chloride? PbCl2, and the name? Lead 2. SN and F? Oh, you can put them capitalized, it doesn't matter. SN and F. SNF2, name. Tin 2 fluoride. And last one, HGS. Mercury 2 sulfide. So these were all examples where they all had the stock system name. It may be mixed in. You might not always have to have the stock system name. How do you know it needs a Roman numeral? It has to be positive in the D block, and it forms multiple ions. Because there are some, like zinc. Zinc is in the D block, but it only forms a 2+ ion. So you do not need to use the Roman numerals for that one. So only ones that form multiple ions. And so here are some where they don't give us the actual ion. What would be the name for this first one? Does everyone agree? Copper 2 oxide? Yep. Why 2 and not 1? Oxygen's -2. To balance out the charges, copper must have been +2. How about this second one? Cobalt 3, fluoride. Fluorine's a -1 charge. There's 3 fluorines, which means a total of -3. So cobalt must have been +3. SNI4. Tin 4. Iodide. And the last one? Iron 2. Sulfide. Okay. That's all the farther we're going to go today.
In a worksheet, I guess?
Yep.
Of course.
So it's just a bunch of naming and writing formulas. Make sure you check to make sure you have a stock system.